Hello everyone. In the previous session we have covered about a process, what are the different states a process exists and what is a process control block, and even we have gone through the context switching. Now in today's session we will be moving on to what are the different process operations that can be performed on a process which is being created. Now when you go for your process operation, we basically have two process operations. One is your process creation, the other is your process termination. Coming to your process creation, it implies that you want to go for creating a process. So you have a parent process which in turn creates the child process, and for that we go for using a system call which we call it as a fork. Now when you go for this fork system call is nothing but which will be implemented in Unix, which goes for creating the child process. System call is nothing but which will make the kernel to work, or it provides the services to the user. Now when you go for executing this fork, you have a parent process and a child process, and the parent process will be given an ID which we call it as PID, process ID, which is 0, and for the child process, depending upon the creation status, it will be given an integer value. Now as you go on creating the process, one process can include the fork and create a child process. Like that, any of the process can go for creating any number of child process. So if you just see this tree structure, this is a sample tree structure which was used in your Solaris operating system, where all these process names, this is the name of your process and this is the ID indicated below that. This is the name of it and the ID indicated to that. And all the process names which you are seeing here, they are nothing but daemon process. Daemon process are nothing but the background process which you will not be creating it, but they are by default existing in your operating system, and they will be executed when you start booting your system. So we will start with a scheduler whose PID is equal to 0, and this parent process goes for creating the three child process or background process. One is your init process, other one is your page out, which is used for your virtual memory to swap in and swap out. The other one is your fh flush, which is used for moving the data between your cached memory to your disk. And you even have inetd, which is used for your networking operation. So this is your parent process, and you can just see this telnet. This is one of your networking background process which is being executed, and the ID of that particular process. And this in turn goes for creating a child process. We call it as a command shell or a C shell, which will go for creating two other child process. One is for your browser, the other for your Emacs editor. So this is an editor for performing your programming applications. So like this, and if you go for this is your desktop login, which will create an accession, a user interface, and you have all the shell and the command shell which are being created. So I mean to say that each process can execute a fork process and create any number of child process, but keep it in mind, as you go on creating the child process, each particular process will be given an ID, and that is nothing but your PID. Now as we have discussed here, these are nothing but your daemon process or your background process, and the purpose of each one of them. As I told you, init is for your initiation process, page out for your virtual memory, flush to move the data or synchronize the data between your cache and the disk, and this is IEETD, which stands for Internet Super Server, which is used for your networking operations to be done, and DT login, which stands for your desktop login, using which a user interface will be created by the user so that he can access your application programs. Now we'll actually see how when you are creating a process. So one parent has created 4 child or 5 children. So in that case, the first important thing which we need to keep it in mind is about your resource sharing, how the resources are being shared among the child process which are being created by the parent. So in the first category, both the parent and children, whatever resource a parent has, the children can use all the resources. Whereas if I going for the second one, the children can only use a subset of the resources available with the parent, and there will not be any kind of sharing between the parent and the children. When I say a resource here resource can be a printer, it can be a RAM or any other physical or external devices which are connected to that particular process. And along with this particular resources, you even have some data. A parent process has assigned some work to the child process. So, in that case, even the data is to be passed to your child process. For example, let me tell you an example. Now, the parent process wants a child process to print some particular file onto a monitor. So, in that case, the parent process has to provide the input file name as well as the output device on which it has to be printed. So, both these two files, input as well as your output, has to be passed as an arguments for performing the operation. So, along with the resources, data is also to be shared between the parent and the child process. Now, you have created a process, assign the resources. Now, the next thing is it has to execute that particular process. So, when you are going for your process execution, parent and children can execute concurrently at the same time, or the parent will wait for the child process to complete its execution, and then later on the parent process will go for its execution. Coming to the address space, as we have seen in process control block, each process when it is being created, it is assigned a memory. So, in that address space, the parent and the child process, both of them uses the same address space, and we have two possibilities here. The child process can execute the same program as that of your parent process, or the child process can have a new program loaded into it so that it starts executing. So, in this case, parent and the child process are executing two different programs. Now, those are the different things. After you create a process, we have seen how the resources are being shared, how you go for executing, and next. Now, you have finished your execution. Now, the next thing is, after you have done with all the work, you want to delete the process. So, it is nothing but your process termination. The process has performed all its operations. So, you have to terminate your process. So, when you want your termination to be done, you can just go for using a system call known as exit, which will terminate the process, and whatever operation is done by the child, the same data or the output will be given back to the parent, and that is using your wait system call. And all the process that are being allocated or the resources which are being allocated to that particular process which is being exited will be deallocated by your operating system. This is your normal termination, whereas when you go for your parent process which has created the child process, so it can normally terminate, the child process can get normally terminated by itself, or the worst cases the parent process abnormally or aborts the child process. Why? Why the parent process will abort the child process? One particular case is the child has exceeded the number of resource allocated, usage of it has been allocated is exceeded, or the task which the parent has given to the child is no longer needed by the parent, or if the parent process itself is terminated. So, if the parent itself gets terminated, then no longer the child will be there in lifetime to execute it. So, the child process will also be terminated. So, and this process we call it as cascading termination, where the parent, if it terminates, all the child process will also gets terminated abruptly. Now, we have just gone through how a process is created and how it is getting terminated. Now, we will see in detail about what are the different system calls that are required for your creation as well as your termination. So, when I go for process creation, we have to concentrate on fork system call and execute system call, and when I go for process termination, I need to take care of my wait as well as exit. So, these are the four system calls which are basically required for you to write a program. You even have a program in your lab exercise where you need to create a child process and a parent process using this system calls. Now, first we will go to the first system call which we call it as fork. Now, when you go for fork here, you first start a process and this particular process will go for executing the fork. So, when you execute this particular fork, this in turn creates the two processes. One you call it as a parent process, the other you call it as a child process. And the syntax of using your fork is P is equal to fork, where P is nothing but it will get an integer value, and that we can even call it as a PID. So, after executing this particular operation, P will contain a value. So, if the value is greater than 0, it is nothing but your parent process. So, if a parent process is created, the ID of this particular parent process will be present in P, and even the ID of your child process will be present in your P. If P is equal to 0, it means that it is a parent process, or you will be even getting the ID of your parent child process. On failure, for example, you have not created. Fork is nothing but a system call. You will not write a code. It has automatically been executed by the system. So if the parent process has not created any of the child process, the return value of it will be -1. So for child process, if I am using a fork here, it gives the ID of the parent, and if you are using a fork here, it gives the ID of the child. Now when you go for your normal system called fork, if you can just see this is a PID of your parent process and this is a PID of your child process. One is 25, the other is 26. So you just see the same set of data will be present the other side also. So whatever program is being executed by your parent process, the same code will be present in your child process also. So when I am executing the fork process, each of the copy of the program of the parent process will be exactly present in your child process. So both of them will be executing the same program. But in this case, I don't want the same copy of the parent program to be executed by the child. I want a separate program to be executed by the child. In that case, we go for using a command known as execute. So when you go for using a command execute, just see this particular structure. This is a code related to your parent process, whereas here the same code is not available in your child process. So in this case, when I perform an execute operation or execute system call, the copy of your parent program will be deleted and whatever program you want the child process to execute, that particular program will be executed by your child process. And remember one thing, this particular EXEC, you cannot use EXEC directly, you can go for using EXECV or we can go for using EXECL. So in either of these cases, we go for having a different program in the child process. And this particular EXEC command is to be used after you call your fork command. It should not be used before your fork command. The next system call what we have here is wait. Now you have a parent and you have a child. So the parent process will wait for the child process to perform its execution, and once the child process has done its execution, then the parent process will resume its execution. So in that case, we go for using an operation known as wait, and the syntax of using this is wait, and to this we will have an integer value which will give you the status of that of your child process, and it even returns the ID of the child process which has been terminated. So your parent process is waiting here and it has to know which of the child process gets terminated. So by seeing this PID T, it will understand that which of the child process has got terminated. So that ID will be present here. So on success, it returns a PID of the terminated child process. Now for example, parent process has not created any child process, but it has executed wait command. In that case, there is no child process existing. So it means that it is a failure and returns you -1. So in place of this W status, where you want to know the status of the program terminated, you don't want to know the status, you can just replace this particular argument with null, NULL. Now, the final system call which you have to execute on the process is nothing but your exit. We have done the completion of the execution statements, then we simply call the exit function which will terminate the program, and all the resources which are given to that particular process will be collected back by the operating system. Now seeing all these system calls, let us go through the transition diagram of a particular process. Now you are a parent, I am just calling a fork process. So when a parent is calling a fork process, this PID contains the ID of the child, whereas if the child process is executing PID is equal to fork, child will contain the ID of the parent. So ID of the parent will be 0, whereas ID of the child will be greater than 0. So if your ID is greater than 0 means that the parent has created a child. So in that case, the parent process will just wait. And if your PID is equal to 0 means that the child process is executing the fork and it is getting the value as 0. So in that case, the child process will execute and after its termination, it goes for exit. And when you are exit, the information will be passed to your wait to the parent, indicating that the child has finished its operation and later on the parent can resume its operation. So it means that the parent process will wait for the child process to terminate, and once it gets terminated, the parent process will continue its execution.